Do not forget, you can support the channel with a like, and you can also subscribe to be aware of the latest published videos. Thank you. We hope that here you can find the latest news, ideas, and discoveries from the scientific world.
Webb Space Telescope shocks astronomers with surprising exoplanet atmospheric composition. Gas giants orbiting our sun show a clear pattern. The more massive the planet, the lower the percentage of heavy elements in the planet's atmosphere. But out in the galaxy, the atmospheric compositions of giant planets do not fit the solar system trend, an international team of astronomers has found. Using NASA's James Webb Space Telescope, the researchers discovered that the atmosphere of exoplanet H-Dun 49026b, a hot Jupiter orbiting a star comparable to our Sun, is superabundant in the heavier elements carbon and oxygen, far above what scientists would expect for a planet of its mass. In addition, the diagnostic carbon-to-oxygen ratio of H-Dun 49026b, also known as smertrios, is elevated relative to our solar system. These findings, published in High Atmospheric Metal Enrichment for a Saturn-mass planet, in the journal Nature on March 27, are an important first step toward obtaining similar measurements for a large sample of exoplanets in order to search for statistical trends, the researchers said. They also provide insight into planet formation. It appears that every giant planet is different, and we're starting to see those differences thanks to JWST, said Jonathan Lunai, the David C. Duncan Professor in the Physical Sciences in the College of Arts and Sciences and a co-author of the study. In this paper, we have determined how many molecules there are relative to the primary component of the gas, which is hydrogen, the most common element in the universe. That tells us quite a lot about how this planet formed. The giant planets of our solar system exhibit a nearly perfect correlation between both overall composition and atmospheric composition and mass, said Jacob Bean, professor of astronomy and astrophysics at the University of Chicago and lead author of the paper. Extrasolar planets show a much greater diversity of overall compositions, but scientists didn't know how varied their atmospheric compositions were until this analysis of H-Dun 49026b. We have shown definitively that the atmospheric compositions of giant extrasolar planets do not follow the same trend that is so clear in the solar system planets, Bean said. Giant extrasolar planets show a wide diversity in atmospheric compositions in addition to their wide diversity of overall compositions. Smertrios, for one, is super-enriched compared to its mass, Lunine said. It's the mass of Saturn, but its atmosphere seems to have as much as 27 times the amount of heavy elements relative to its hydrogen and helium that we find in Saturn. This ratio, called motility, is useful for comparing a planet to its home star or to other planets in its system, Lunine said. Smertrios is the only planet known in this particular planetary system. Another key measurement is the ratio of carbon to oxygen in a planet's atmosphere, which reveals the recipe of original solids in a planetary system, Lunine said. For Smertrios, it's about 0.84 higher than in our solar system. In our Sun, it's a bit more than 1 carbon for every 2 oxygen atoms. Together, these observations paint a picture of a planet-forming disk with abundant solids that were carbon-rich, Lunine said. H-Dun 49026b acquired large amounts of this material as it formed. While an abundance of carbon might seem favorable for chances of life, a high carbon-to-oxygen ratio actually means less water on a planet or in a planetary system, a problem for life as we know it. Smertrios is an interesting first case of atmospheric composition for this particular study, said Lunine, who has plans in place to observe 5 more giant exoplanets in the coming year using JWST. Many more observations are needed before astronomers can discover any patterns among giant planets or in systems with multiple giant planets or terrestrial planets to the compositional diversity astronomers are beginning to document. The origin of this diversity is a fundamental mystery in our understanding of planet formation, Bean said. Our hope is that further atmospheric observations of extrasolar planets with JWST will quantify this diversity better and yield constraints on more complex trends that might exist.